Okay guys, welcome back. So in the last video I talked to you about two examples of horizontal asymptotes. So in this video I'll be talking about two examples of vertical asymptotes. So in one of my previous videos I talked to you as to how vertical asymptotes can be found. So this video will be of great importance to you because if you're finding now, I explained to you about horizontal asymptotes. So if we have a broad understanding about finding the vertical asymptotes with some examples, you will easily find it easier when you are drawing graphs and the other concepts regarding these asymptote problems. Alright, so in this video I'll be talking about two examples in which vertical asymptotes are necessary. Right, vertical asymptotes have to be found. So my first example will be a function like this. So if we give something like this, so fx is equal to x cubed plus 5x squared plus 6 divided by x squared plus 6x plus 8. Right? X squared plus 6x plus 8. So if you have some function like this, what you have to do actually is, now if you have to find the vertical asymptotes of this function, what you have to do is that, as I mentioned in one of my previous videos, you have to find the factors of the denominator. Now you have x squared plus 6x plus 8 here, so the factors will be 4 and 8. Now you can find, if you are well versed of finding factors directly, you can find it either from the common quadratic equation, and also you can substitute it to 0 and find it separately by factorizing out. So there are many ways to find this. You can square this, and using the square method also you can find this. So I'll directly factorize, right? It's easy, right? Two easy factors. Those will be plus 4 and plus 2. So I can also write this one as this function as x cubed plus 5x squared plus 6 divided by x plus 4 times x plus 2, x plus 4 times x plus 2. So this is a factorization of the denominator. Alright, so you know by the concepts of finding vertical asymptotes. Now in order for you to find the vertical asymptotes, what you have to do is that you have to equalize this to 0, the denominator to 0. So what actually happens is that you will get vertical asymptotes, vertical asymptotes vertical asymptotes when x plus 4 is 0 and x plus 2 is 0. So those will be x equals minus 4 and x equals minus 2. Now if you draw this in a Cartesian axis, what you get here is like this way. X and y. So one will be minus 4 and the other will be minus 2. So I'll say this one as minus 2 and this one as minus 4. What I'll do is I will draw this. So one will be like this and the other one will be like this. Right? Simple. So if you have some function, you will get an upper hand value or lower hand value here, and some function here this way, some function this way, and some function here. So that actually depends on, I am not going to draw the graph here. So you cannot cross this, right? You can cross this means you have just to have some shape that is just merely touches this line, touches these two lines, right? If it is between and if it is on the left and the right, so it merely touches these two lines, not actually touching, right? Merely touches, not touching, just merely touches. Now if you have something like this and this merely touches means just like this, and function like this. Now what I mean by by touch is directly touching like this, right? Somewhere here, directly touching. So this is touching and this is merely touching, right? Merely touching means just you see that just like touching, but actually not touching, right? So this is one example of finding vertical asymptotes. Now actually I found many examples of finding vertical asymptotes in my lectures of finding the asymptotes of functions. So these are just two more examples in this video I'll be talking about. So my second example and my last example on vertical asymptotes will be this function. So I'll take a function like this, a simple function, much simpler. So fx equals x plus 1 divided by x squared plus 5x plus 4, right? X plus 1 divided by x squared plus 5x plus 4. So again what you'll do is that you have to actually factorize the denominator. So I don't have to factorize using the equation or any other concept. What I have to do is I can just see that the factors are 4 and 1. Factors are 4 and 1. So I'll write directly this as x plus 1 divided by x plus 1 times x plus 2, right? X plus 1 and x plus 2. Now what actually happens, sorry, x plus 4, right? X plus 4. X plus 4. Now what actually happens is that now you can't cancel this x plus 1 and this x plus 1, because you can't say that this function x is not equal to minus 1. So if you draw some function like this, if you draw a function for this, you can say that x is not equal to minus 1, right? So you have to find that. So you can actually cancel. Now let's see as to what happens, right? As to what happens, right? However, you know that if you have something like this, that what actually happens is that in order to find the vertical asymptotes, we have to equalize these two separately to 0. So the vertical asymptotes will be vertical asymptotes will be when x plus 1 will be when x plus 1 is equal to 0 and x plus 4 is equal to 0. So that will be x equal when x equals minus 1 and when x equals minus 4. Right? When x equals minus 1 and when x equals minus 4. So let's draw it on the graph on the Cartesian axis and see what happens. So this is my x-axis, this is my y-axis, like this. So here will be, I'll take here to be minus 1, here to be minus 4. So my axis will be like this. So the vertical asymptotes will be like this. One here and another one here. Right? And another one here. So can you see now when x is not equal to minus 1, right? When x is not equal to minus 1. So what actually happens is that if you solve like this, right? If you solve like this, you will actually get x is not equal to minus 1, right? X can't be equal to minus 1, x just goes to minus 1 like this, minus 1, something like that, right? It merely touches, as I mentioned in the first part of this video, it merely touches. Now this is touching and this is merely touching, right? So this is touching and this is merely touching. It's actually not touching, but we see that's actually an optical illusion. We see that it's actually seems to be touching, right? So whether this is touching or not, right? You get asymptotes here, means it's actually merely touching. So x can't be equal to minus 1. Can't be equal to minus 1, right? So you can't get something like that. So you can also differentiate this using that x is only equal to minus 4, right? The only asymptote is minus 4, and you can solve for that. So that's an example in which I have not taught you in my previous videos. I explained to you only the concept that you can just divide like this, you can equalize it to 0, and you can find that. But now you learn that if you have the same term in the numerator as well, you can cancel these terms, because you will get that this to be not equal to minus to that term, even though you solve without cancelling out. So that's just a simple example and a further elaboration of the concepts of vertical asymptotes. So those two examples are the final examples I'll be teaching you on vertical asymptotes. So I'll see you next time with a new topic on calculus. See you then.